I am Dr. Gitanjali Mehta from Galgottias University. So today we are going to discuss about the periodic functions, the average and the RMS values. The objectives of this lecture: learning about the sinusoidal alternating voltage and current, the important AC terminologies, the average value, the RMS values, the form factor, and the peak factor. So as we all know, the commercial alternators produce the sinusoidal alternating voltage. That is, alternating voltage is a sine wave. A sinusoidal alternating voltage can be produced by rotating a coil with a constant angular velocity in a uniform magnetic field. The sinusoidal alternating voltage can be expressed by the equation V is equal to Vm sine omega t. The small letter v denotes the instantaneous value of alternating voltage. Vm denotes the maximum value of alternating voltage. Omega represents the angular velocity of the coil. Sinusoidal voltages also produce sinusoidal currents unless the circuit is non-linear. Therefore, a sinusoidal current can be expressed in the same way as voltage. I is equal to Im sine omega t. Sinusoidal voltage or current not only changes direction at regular intervals, but the magnitude is also changing continuously. The different AC terminologies. The shape of the curve obtained by plotting the instantaneous values of voltage or current as ordinate against time is called its waveform, as can be seen from the figure. The value of an alternating quantity at any instant is called instantaneous value. The instantaneous values of alternating voltage and current are represented by V and I respectively. As an example, the instantaneous values of voltages at 0 degrees, 90 degrees and 270 degrees are 0, Vm minus Vm respectively. One complete set of positive and negative values of an alternating quantity is known as a cycle. A cycle can also be defined in terms of angular measure. One cycle corresponds to 360 degrees or 2 pi radians. The time taken in seconds to complete one cycle of an alternating quantity is called its time period. It is generally represented by capital letter T. The number of cycles that occurs in 1 second is called the frequency of the alternating quantity. It is measured in cycles per second or hertz. The frequency of power system is low, the most common being 50 cycles per second or 50 hertz. It means that alternating voltage or current completes 50 cycles in 1 second. Amplitude, the maximum value attained by an alternating quantity, is called its amplitude or the peak value. The amplitude of an alternating voltage or current is designated by capital letter V with a small m or Em or Im. Moving on further, an alternating voltage or current varies from instant to instant. And an alternating voltage or current can be expressed by its peak value, by its average value or mean value, RMS value or effective value, and peak-to-peak value. Although peak, average, and peak-to-peak values may be important in some engineering applications, it is the RMS or the effective value which is used to express the magnitude of an alternating voltage or current. So peak value is the maximum value attained by an alternating quantity. The peak or maximum value of an alternating voltage or current is represented by Vm or Im. The average value of a waveform is the average of all its values over a period of time. We regard the area above the time axis as positive area and the area below the time axis as the negative area. The algebraic signs of the areas must be taken into account when computing the total area. The time interval over which the net area is computed is the period t of the waveform. So average value is the net area under curve for time t divided by the total time t. The average value of alternating current or voltage over one cycle is 0. It is because the waveform is symmetrical about time axis and positive area exactly cancels the negative area. However, the average value over a half cycle is not 0. Therefore, average value of alternating current means half cycle average value unless stated otherwise. So the half cycle average value of AC is that value of steady current which would send the same amount of charge through a circuit for half the time period of AC as is sent by the AC through the same circuit in the same time. It is represented by I with a small AV. This can be obtained by integrating the instantaneous value of current over one half cycle and dividing the result by base length of half cycle. So the average value IA is equal to area of half cycle divided by the base length of half cycle. The area of calculated by taking a small strip at an angle of theta with a width of d theta. So the area of the strip becomes I d theta. The area of the half cycle is equal to integration from 0 to pi I d theta, substituting I with its value of Im sine theta and integrating, we get Im minus cos theta with the limits of 0 to pi that comes out to be 2Im. So now calculating the average value, it comes out to be 2Im upon pi, that is equal to 0.637 times of its Im. Hence the half cycle average value of AC is 0.637 times the peak value of AC. Coming to the effective or the RMS value, it is that steady current which when flowing through a given resistance for a given time produces the same amount of heat as produced by the alternating current when flowing through the same resistance for the same time. For example, when we say that the RMS or effective value of an alternating current is 5 ampere, it means that the alternating current will do work or produce heat at the same rate as 5 ampere direct current under similar conditions. AC ammeters and voltmeters record RMS values of alternating current and voltage respectively. To calculate the RMS or the effective value, we take the square of this I waveform and again we consider a small strip at the angle theta with a width of d theta. So calculating the area of the strip, it comes out to be I squared d theta. And the area of half cycle of the square waveform will be integral from 0 to pi I squared d theta. Again substituting the value of I and integrating, it comes out to be pi Im squared upon 2. Now the IRMS is defined as the under root of the area of the half cycle squared wave divided by the half cycle base. So substituting the values, IRMS comes out to be 0.707 times of Im, or it is Im upon root 2. Similarly, it can be proved that for alternating voltage varying sinusoidally, VRMS is equal to 0.707 times of Vm. There exists a definite relation among the peak value, the average value, the RMS value of an alternating quantity. The relationship is expressed by two factors, namely form factor and peak factor. So the ratio of RMS value to the average value of an alternating quantity is known as form factor. The value of form factor depends upon the waveform of the alternating quantity. Its least value is 1, for example, for square wave, rectangular wave, and may be as high as 5 for other waveforms. The form factor for an alternating voltage or current varying sinusoidally is 1.11. The form factor gives a measure of the peakiness of the waveform. The peakier the wave, the greater is its form factor and vice versa. For instance, a sine wave is peakier than a square wave. Hence, the former has a greater form factor of 1.11 than the latter. Similarly, a triangular wave is more peaky than a sine wave and has a form factor of 1.15. So form factor is defined as the RMS value upon the average value. So for a sinusoidal voltage or current, form factor can be represented by 0.707 into the maximum value, that is the representation of RMS value, divided by the average value that can be represented as 0.637 times of its maximum value, and the ratio, it comes out to be 1.11. So for a sinusoidal voltage or current, the form factor is 1.11. The ratio of the maximum value to the RMS value of an alternating quantity is known as a peak factor. The value of peak factor also depends upon the waveform of the alternating quantity. For an alternating voltage or current varying sinusoidally, its value is 1.414. The peak factor is of greater importance because it indicates the maximum voltage being applied to the various parts of the apparatus. For instance, when an alternating voltage is applied across a cable or capacitor, the breakdown of insulation will depend upon the maximum voltage. The insulation must be able to withstand the maximum rather than the RMS value of the voltage. The peak factor is also called the crest factor or the amplitude factor. So peak factor is defined as the ratio of the maximum value to the RMS value. For a sinusoidal voltage or current, peak factor comes out to be equal to maximum value divided by the RMS value has been substituted as 0.707 times of its maximum value, and the ratio comes out to be 1.414. So today we have discussed about the sinusoidal alternating voltage and current, the different AC terminologies, the average value, the RMS value, the importance of the form factor, the peak factor. So these are the references given there. Thank you.